Geometry Chapter 7, Section 3, we're talking triangle similarity theorems as we do this. So we'll break it down. There are three things like with our congruency theorems that we want to work with. First one we're going to choose is side-side-side similarity. And for side-side-side similarity, all three pairs of corresponding sides are proportional. They're all proportional, meaning that we got to compare them all, set them up as fractions. They all reduce to the same fraction. If you don't want to reduce them, remember we talked about you could do cross products. Same scale factor if you want to do that. We got three things that you can check out on that. So let's look at an example here. Wow. All right, drawing is horrendous right now. Point E right there. E to D is 4 units. So you got a combination going on here of figures. So split them up. And as we split them up, notice this isn't the reflective property. It only goes to here. So we have triangle ABE. Five, 4, 3, and triangle D, B, C. 10. This whole thing is 4 plus 4, 8, and 6. Some of you might be able to see it right away. Awesome. That's fine if you can. Others, let's set up our proportionality statement. Or, I'm sorry, we'll check our ratios. So I'm seeing a 3 to 6. I'm seeing a 4 to 8. And then I'll go 5 to 10. Some of you will see that they all reduce to 1/2, which is good. Some of you will see 24, 24, 40, 40, and then I got check 30, 30. We got the same cross products. So it checks. So now that we got the check, write our proportionality statement. It would look something like this, taking our numbers and just putting the letters. So AB compared to BC equals EB compared to DB and AE compared to 2DC. In this case, we made the same comparison of left to right or small to large. Just depends on how you want to look at that. Theorem number 2 will be side angle side similarity. Side angle side similarity. Here we must have two pair of corresponding sides in proportion. Easy. Two pair corresponding side in proportion, and the included angle congruent. The included angle has to be congruent. So let's look at a diagram. So looking at this diagram, let's call it this. We'll go 8 units, 10 units, 4 units, 5 units. You should be able to see that we have two triangles involved here, so we are going to separate them and see what we have. You got the smaller one on top. And then we've got the larger one, which uses a small one. And we've got 15 and 12. You should notice, at least I hope you notice, that they're sharing angle A, so the reflexive property is being used. So our angles are congruent. So we're looking at the angle between these two sides and between these two sides. So let's make a comparison. I'm going to choose small to large simply, or left to right. I'm comparing 8 over 12 to 10 over 15. Again, reduce, or I'm going to cross product this. There's 120, and that's also 120. So they check. So that was comparing AB to AC, and it is proportional to AE to AD. All right. And the reflexive property, we got to use angle A with that. So now if I wanted to write a similarity statement about these two, again, you choose a triangle. I'm going to choose triangle A, B, E. I'm going to say it's similar, but now make sure you're putting the corresponding angles in the right spots, please. Start with A, so A, following suit, C, D. Third and final theorem then is called angle-angle similarity. For this one to work, you got to have two pair of corresponding angles that are congruent. And the key ingredient here is going to be corresponding. Key ingredient will be corresponding. So as we look at our first diagram, well, I got a 40-degree angle, 60-degree angle, about like 60 here, 40 here. I can flip flip the triangles over and do this. Now, what else is going to be in favor here? Well, think about it. If two angles of one triangle congruent to two angles of another, what do you know about the third angles? Right? Third angle theorem will be used, or can be used. So you can pick any pairs that you want. All right, but given information, angle A is congruent, angle X, angle B congruent to angle Y. That's all we need. The third angle is going to be congruent. Now, for our statement, it's all about putting the angles in the right order. So let's see. I want to go triangle B, A, C. Similar. So I went 40-degree angle, 60-degree angle, and I'll say unknown, but we can figure it out real easy. So I got to go to the same order. So I got to start with a 40-degree angle. So triangle Y, 60-degree angle X, and then the one that was unmarked. There's your similarity statement, angle, angle, similarity. Now, talk about another scenario. So as we look at this one, do we have enough information to present angle, angle, similarity? Well, hopefully you see there's two triangles here, but no sides are marked, like previous examples where we had sides to work with. But you have all sorts of things here to work with. First and foremost, we got parallel lines. Parallel lines, transversal on this side, transversal on this side. So look at it this way. Angle W and angle X are congruent to each other. Reason. Parallel line, transversal. Their corresponding angles of parallel lines. Angle Z is congruent to angle Y. Why? Parallel, transversal, same reason. And you can really say that angle V is in both triangles. Reflexive property. Third angle theorem. I mean, whatever route you see or what you want to go with here. Meaning what? Well, depending on the diagram, you got a lot of options here to come up with the right answer. So they're similar by angle, angle, similarity. So let's make a statement. Our statement could say, a small triangle, we'll go V, W, Z, similar. So how'd I go? Went no to a single to a double. So in the big triangle, I got to go no, single, double. V, X, Y. Angle, angle, similarity. All right, let's look at our third example then. In our third example, we have the following. Different options happen here. You've got parallel line by markings, so you got some given information. We can declare that angle M is congruent to angle Q. We can declare angle L congruent to angle P. You say the reason while I write this stuff out. Hopefully you came up with a reason, since this is my transversal, parallel, alternate interior angles of parallel lines. But along those same lines, you don't want to use both of those. You can go here. I can't call it angle O. There's 4 angles there, but I can say angle MOL is congruent to angle POQ. Reason, they're vertical angles. So again, we're up to making a congruence statement. Let's say, let's go triangle MOL. Similar, I said congruence, sorry, similar statement. Follow the same suit, 1, 3, 2. So I gotta go 1 to 3 to 2. Triangle QOP. Now with this being said, you now know the sides. Segment MO is proportional to segment QO, OL proportional OP, and ML proportional to QP. Use these. You've got worksheet 7.3 to do now. Do what you need to understand it, but make sure you're logging your work into the Google Classroom so I can give you credit on it.